Lecture number 6, forces and equilibrium. So we are starting off with frictional force. So what is your frictional force? First of all, we need to understand that. So a frictional force is a force which resists the motion of an object. Resists the motion of the object due to contact between two surfaces. Frictional force, let's say it always acts parallel to the plane, to the plane. So that means it is always parallel. If the plane is horizontal, then frictional force will be horizontal. If plane is vertical, it will be vertical. If plane is inclined, it will be inclined. So it always acts parallel to the plane. In opposite direction to motion. In opposite direction to motion. Now, for frictional force, I would say that you should be knowing frictional force is equal to coefficient of the friction multiplied by normal reaction. So that means your frictional force is basically coefficient of the friction will be given mu, coefficient of the friction, considering that it is mu, and your normal reaction will be what? R. SI unit for this is again Newton. Now, considering that there is an object, right? This object is on the what? Plane. Now, knowing that there is a force being applied, right? The weight of this is 10,000 Newton. Let's say there's a frictional force being applied on this, right? So, your coefficient of the frictional force is 0.7. So, knowing that weight is 10,000, so your normal reaction would be 10,000 as well, right? Because if there is a vertical force, then obviously vertical force downward, your normal reaction would be towards upward. Knowing that mass is 1000 kgs, let's just write down mass as 1000 kg, then your coefficient is 0.7. Your coefficient is 0.7. So you guys agree to this that whenever we need to find the frictional force, we need to understand that frictional force is coefficient of the friction, which is 0.7, and the normal reaction, which is always perpendicular to the plane, which is what 10,000 itself. So if I want to find out the frictional force, so your frictional force will be mu r. So frictional force will be 0.7 to what? 10,000. So this is what? Frictional force is 7,000 Newton. So that means if the frictional force needs to be applied when the coefficient is 0.7, we need to understand that the normal reaction is 10,000. So the frictional force being applied on the ground, that means ground level of the frictional force is what? 7,000 Newton. Now, remember this, that for suppose, let's say that there's a car, right? I will always give an example of a car. If a force is being applied to the car and the direction of the car is this point, right? So the frictional force will be opposite to the force because the ground friction will be there. So we need to find out that frictional force. For that frictional force, we use what? Mu r, for which the coefficient is 0.7, and obviously the ratio reaction was what? 10,000. So let's just now work on the three types of frictional forces impact on the object. Now the frictional force impact, if we just work upon that, let's say that if the three thing that if force is less than 7,000 Newton now, if the force being applied is less than 7,000 Newton, so the object will be in equilibrium state because the force is less than the frictional force. If if the force is equal to 7,000 Newton, so this will also be in the equilibrium form, but it will be known as the object in limiting equilibrium. That means it is about to move. Limiting equilibrium. Then the third point is if force is greater than 7,000 Newton, if the force is greater than 7,000 Newton, then the object basically accelerates. The object basically accelerates in the direction of the force. In the direction of force. So these are the 3 points that we will be working on when we are dealing with frictional force. As we all knew that the frictional force was 7,000. So we worked upon the 3 major things, that if the force is less than 7,000, the object is in equilibrium. If the force is equal to 7,000, the object is in limiting equilibrium. And when the force is greater than 7,000, then that means object accelerates in the direction of the force. Okay, moving further, let's say that your frictional force acting on horizontal surface. So one thing that we need to understand is there is a block and there will be force, that will be your applied force, and there will be one thing that is known as your frictional force, right? There would be a plane as well. So let's say that your force, applied force, is greater than your frictional force. So that should be force resultant, force applied minus your frictional force. And force resultant is basically what? Your MA. That means force applied minus frictional force. So if I want to find out the acceleration, so what I need to do is force applied minus frictional force divided by its mass. So I will be getting the acceleration of this. So now you need to understand that the force resultant is equal to the force applied force minus the frictional force. So force resultant is also known as your MA, right? Initially, what we made sure when we did lecture number 1, we worked upon the force resultant, right? We did FR is equal to what? MA. And what we used to do is FR was divided by its mass to get the acceleration. So even today, your force resultant, your unbalanced force was mass into acceleration, which was your force resultant. So today, even in lecture number 6, since we are doing frictional force, you should be agreed to one point that force applied is it greater than frictional force, which means force applied minus frictional force will be the force resultant. And when we have force resultant, your force resultant is basically MA, right? So A, to find out accelerating your A is M is divided by what? Force applied force minus your frictional force. Let's just work upon the another object. Let's say this is your block and this is your plane. Now there's a force being applied diagonally. Now there's a force being applied diagonally. Let's say there's an angle as well. So we know one thing, that there would be weight which will be known as your mg, right? This should be at this point, there would be two directions on the right hand side towards up. This should be f sine theta and this should be f cos theta, right? So if I need to find out the resultant reaction of this, your reaction towards this would be mg minus f sine theta. Mg minus f sine theta. Now, you know one thing, that since force is applied here, right? So the object will move in this direction. Since the object will move in this direction, your frictional force will be in the left-hand side direction. That means this will stop the object, right? So this will move on the left-hand side direction. So let's just say that your frictional force is moving on the left-hand side. So now what you need to understand, that if F cos theta is less than frictional force, this should be your F cos theta, because this is moving on the right hand side, your frictional force is moving on the left hand side. If F cos theta is less than the frictional force, so we know one thing, that the object will be in equilibrium. If F cos theta is equal to frictional force, so this is your limiting equilibrium. Limiting equilibrium. This will be your limiting equilibrium. If F cos theta is greater than frictional force, that means it will be accelerating towards the force. Accelerating towards the force. So what we need to understand is, your force resultant normally is for F cos theta minus frictional force. So this is your MA. So F cos theta minus frictional force. So A will be F cos theta minus mu R upon M. And the R that we had was cos theta minus mu. And the R we had was mg minus, this is your R. Now we know that R is what? Mg F minus F sine theta. So we're going to write it down here. In the place of r, that would be mg minus f sine theta, which will be upon m. So this will give me my acceleration on the vertical, on the horizontal force. Remember that frictional force is mu r, and the r that we got was from what? Your vertical force towards down and vertical force towards up. So obviously we're going to subtract it. We got R. Friction force is mu R. So R is the value of mg minus f sine theta. Remember this, that Fr will be force that is being applied force minus the frictional force. So applied force is F cos theta because it is moving on the right hand side, and the frictional force will be on the left hand side. Okay, let's just work upon the frictional force acting on the vertical surface now. Frictional force acting on vertical surface. So what we need to understand is, let's say that there is a rod, vertical rod. Let's say there is a ring. The weight of this will be downwards, which will be what? Mg. Considering that it's a ring and it is the frictional force applied will be 0, your Fr is basically your weight. So that means Fma is equal to mg. So mm is cancelled. So that means A becomes what? G. So can we just say that acceleration becomes what? Your gravity when the ring is on the vertical side. So let's just work upon the normal examples when the force is being applied diagonally. When the force is being applied diagonally. So can we just say that there's a rod, right? And there is a ring. Now the force is applied diagonally with the theta. So the weight acts downwards. So that means W is equal to mg. So if W is equal to mg, so what we can have is, we can solve this with two different forces that should be towards up and right. So this should be F is equal to sine theta, and this should be F is equal to cos theta. So if it's a vertical plane, it's a vertical surface, right? So since it is vertical, you should be agreeing to one point, and that is that the reaction would be horizontal. So if the force is being applied on the right hand side, so your reaction would be on the left hand side. So let's say your reaction is here. So this should be F sine theta as well. Now, if we just look at this, that the case says the object is moving downwards. Downward moving object. Right? So if it is moving downwards, then the frictional force acts upward. If the object is falling downwards, then the frictional force what? Acts upward. So if I need to find out upward force, if I need to find out the upward force, so what I need to do is upward force will be F cos theta, right? Plus the frictional force, because there are two forces, no? One is F cos theta, and obviously, if it is dropping, there would be another frictional force being applied as well. And the downward force will only be one thing. The downward force will be only the weight itself. Only the weight. So if we just need to find out the FR, so how do we find out the FR? Your FR will be weight minus, because it is falling downwards, F cos theta plus frictional force. F cos theta plus frictional force. So this is MA is equal to mg minus F cos theta plus mu r plus mu r. So MA is equal to mg minus F cos theta, and this was what? Mu F sine theta. This was F sine theta. So A will be mg minus F cos theta plus mu. It should be F sine theta upon A. So this will be the finding out the acceleration upon m. Sorry, this will be finding out the acceleration when the frictional force is being applied and in the vertical surface the object is dropping downwards. Now in the same diagram, if we just work upon case 2, let's say that in case 2 it is upward moving. If it is upward moving, so what we need to understand is that frictional force will act downwards. Your frictional force will act downwards. So your upward force will only be F cos theta, and your down force will be your weight plus your frictional force. But since we know that the object is moving upward, so obviously the resultant force will be majorly on the upward ground. So if it is upward, so what we can have is that FR is equal to F cos theta minus weight plus frictional force. And the frictional force is what? FR is equal to F cos theta minus mg plus mu, and your resultant force is again F sine theta. Resultant force is F sine theta. So FR is what? MA, right? So if this is A, so F cos theta minus mg plus mu F, this should be sine theta upon what? M. Because here at this part you need to understand that your FR is MA. So when A is here, your M will be divided on the other side. Your reaction was F sine theta, because if you knew that it was a vertical force on the right hand side, you are using, your reaction was, if you just look at this, your force on the right hand side was F sine theta, so your reaction is F sine theta on the left hand side, right? So this becomes your force being applied towards left hand side. So when we need to find out the MR or mu R, in place of R you have S sine theta, your weight is mg F cos theta, since it is moving upward, so F cos theta will be written first, whereas the force acting downward will be subtracted.